Welcome to InfinityCast, where we explore the frontiers of science and technology. I'm your host, Elion Quanta. Today, we're looking at a field where the best inventor isn't a person in a lab, but evolution itself. We're talking about bio-inspired engineering. And to help us break down this fascinating topic, I'm joined by my co-host, Theo Lumis. Welcome, Theo.
Great to be here, Elion. It's a topic I find endlessly fascinating. We spend billions on research and development, but nature has been running the ultimate R&D lab for about 3.8 billion years. It's essentially a massive open-source library of tested, optimized, and incredibly efficient solutions.
That's a perfect way to put it. So instead of reinventing the wheel, we're learning from the master craftsmen. Let's start with a classic example that feels like something out of science fiction: adhesion. Specifically, how do you get something to stick to a surface like a vertical glass wall without any messy glue?
You look at a gecko. A gecko's ability to scurry up walls and hang from ceilings is legendary. For the longest time, we didn't fully understand it. It's not suction, it's not a chemical adhesive. The secret is physics at a microscopic level. Their feet are covered in millions of tiny hair-like structures called setae.
And these setae branch out into even smaller tips, right? To the nanoscale.
Exactly. They're called spatulae. This massive increase in surface area allows them to take advantage of a subtle intramolecular force known as the van der Waals force. It's a weak attraction that exists between all molecules, but when you have billions of contact points like a gecko does, that weak force becomes incredibly strong enough to support its entire body weight on one foot.
So how are engineers translating that? I've heard about robots that can climb walls.
Precisely. Researchers have developed gecko tape and adhesive pads that mimic this structure. You can use it for robots that inspect pipes or skyscrapers, or even in delicate applications like surgery for grippers that can handle tissue without causing damage. And the best part? It's reusable and leaves no residue. Just peel it off and the force is gone.
Incredible. It's solving a problem by understanding the fundamental physics rather than just copying the biology. Let's shift from sticking to unsticking. I'm thinking of self-cleaning surfaces. How does nature handle staying clean?
For that, we turn from the animal kingdom to the plant kingdom, the lotus leaf. You've probably seen how water beads up on a lotus leaf and just rolls off. This is called the lotus effect, and it's a masterclass in surface engineering.
So it's super water repellent, or super hydrophobic as it's technically called.
Correct. And again, the magic is in the microstructure. The leaf surface is covered in microscopic bumps, which are themselves coated in waxy nanoscale crystals. This combination creates a surface that barely allows water to touch it. A water droplet sits on top of these points, trapping a layer of air underneath, which minimizes adhesion. So when a droplet rolls off, it picks up any dirt particles along the way, effectively cleaning the leaf.
That seems almost limitless. Self-cleaning windows, paint for buildings that never needs washing, coatings for solar panels to maintain peak efficiency, even water-repellent fabrics.
Absolutely. It's about designing materials that interact with their environment in a specific, desirable way, all based on a principle perfected by a plant. It's a far more elegant and sustainable solution than blasting a building with water and chemical detergents.
What I find so profound here, Theo, is that these aren't just clever hacks. They are deeply efficient, low-energy solutions. Nature doesn't have the luxury of wasting energy. It's a powerful lesson for our own engineering endeavors as we aim for a more sustainable future.
Couldn't agree more. Biomimicry isn't just about cool new gadgets. It's about a fundamental shift in design philosophy towards integration, efficiency, and sustainability.
A perfect thought to end on. That's all the time we have for today. My thanks to Theo Lumis for shedding light on nature's genius. Join us next time on InfinityCast as we explore the future of personalized medicine.